Dear students, let's consider an activity which you must have done or observed number of times. When you place a rubber ball in a bucket of water, it floats. A large part of the ball remains above the surface of the water and rest of it remains below. If there were no bucket, then it would have fallen straight to the ground due to its own weight. But here, some fluid in the form of water is present, which is stopping the ball over it. If you push the ball downwards, a larger part of the ball goes inside water. And to keep the ball at rest in this position, you have to keep on pushing it with the same force. Ever wondered, why do you need to push the ball downwards to keep it at rest inside the water? You got it right. It is done to prevent the ball from moving up. When you push the ball down, you can feel the upward force acting on it, which is helping it to float. And if you release the immersed ball, it will move up to the surface of water. So what pushes it up? This upward force exerted by fluid on an object placed in it is called buoyant force. This force is also known as upthrust. This tendency of fluid to exert an upward force on an object placed in it is called buoyancy. Now the question arises, what is the magnitude of this force? There is a simple rule to find it. When an object is immersed in a liquid, it has to displace some liquid to make space for itself. The force exerted by the liquid on an object is equal to the weight of the displaced liquid. When an object is completely immersed in a liquid, the volume of the displaced liquid is same as that of the object. When an object is partially immersed, it displaces a smaller volume of the liquid. The volume of the liquid displaced is equal to the volume of that part of the object which is inside the liquid. The upward force exerted on the object by the liquid in each case is equal to the weight of the displaced liquid. This was discovered by a Greek mathematician called Archimedes and is summarized as Archimedes' principle. Archimedes' principle states that when a solid body is partially or completely immersed in a fluid, the fluid exerts an upward force on the body, whose magnitude is equal to the weight of the displaced fluid. Now there's a story about how Archimedes happened to formulate this principle. He was once asked by King Hiero to determine whether his crown was made of pure gold or was alloyed with silver or some other lighter metal. The method for doing this occurred to him while he was taking bath. When Archimedes stepped into his bathtub, he saw the water spilling out. A very common sight. But that day, by seeing it, something clicked in his head. He got so excited that he jumped out of the tub and started running through the city, shouting, "Eureka, Eureka," which meant, "I have found it." But what did he find? He noticed that he displaced volume of water while lying in his bathtub. It occurred to him that objects of the same weight but made of different materials would displace different amounts of water. Thus, from the volume of the displaced water, one could tell whether the crown was made of pure gold or not by comparing it with the volume of water displaced by the same weight of gold. Whatever he found out is today famously called as Archimedes' principle of flotation. So we will be doing 2 practicals based on this concept in the very next class.